Hi everybody, welcome to EGG202. I'm Jimmy, I will be the instructor for the course, and I'm going to also be designing these videos to help us with C# along the way. Now, these videos are designed mostly as lectures in a sense to kind of familiarize us with the material before we have our lab assignments. Now, the issue is that in our labs, we have approximately an hour and 45 minutes to work on stuff, and we don't want to waste too much time with me just sort of talking. So these videos are going to just help us prepare ourselves for the labs that are coming up. So I may not have sort of a video for each week, because what could happen is you could have several weeks of lab, and one of the videos really kind of covers more than one possible lab. So this might not be a weekly thing, but I'll have videos set up which will be helpful, that will definitely assist you with the labs you're going to have throughout the semester. So just sort of a replacement for lectures, so we can just sort of work on our content in class. So the first thing you might wonder is, well, why did I choose C#? Well, the first thing is, of course, in your regular CS classes, you get a chance to program in C++, and you get to use this terminal-based environment, which is very important. And it's important to understand the concepts of programming and data structures and so forth, but this is a chance to sort of do some more fun type applications. So of course we're going to start off with doing just basic command line based interface for C#, and at a certain point we're going to change gears into a more graphical user interface, or GUI for short, GUI development we're going to be doing with C#. So it's a very nice package. So C# with Visual Studio is a very nice package to be able to design these desktop apps. So of course there are other types of frameworks you can use instead of .NET and C#, but C# is a very easy language to work with GUI development. And of course Visual Studio is a very nice environment to be able to install different packages needed for C# and different sorts of, if you want to work on web or you want to work on desktop apps and so forth, it's a very nice nifty sort of editor to install extra packages onto. The only downside of this is that, well, this is going to only work just for Windows. Now I know there is Visual Studio for Mac, but if you want to do this GUI development, you have to have a Windows PC to do this. Now in the labs we're going to be working with, which is why I have our lab, I sort of allocated computer lab space which have Windows on those, so we can use those in class, in our lab class, to be able to work on these. Now on my Mac, I do have Boot Camp running, or if you can have a VMware running on your Mac, you can install Windows on your Mac like that, which I have, which I can run and sort of work these, or I can work on this C# GUI development. The problem now, however, is that, at least at this moment in time, the Macs use these fancy M1, M2 chips, which are their proprietary type chips, and I believe that Windows does not run on those chips, so you won't be able to install Windows on your Mac either. So the only good news is that there are several computer labs on campus that also have Visual Studio as well, where you'll be able to actually work in those labs as well. Now each lab would only take an hour and 45 minutes. Now towards the end of this semester, we're going to have a final project that's going to take up, maybe more than one lab session. And of course, you can work on the project, outside of lab hours. If you have your own computer, of course, you can install Visual Studio. And if you don't have a Windows machine, of course, you can use the machines on campus to be able to also work on these, since everything's back in person now. So that's the introduction of, I guess, the course and I guess Visual Studio. So the first thing you're going to want to do is, the first thing you're going to do is going to go and click on Create New Project, and then let's go ahead and then we can sort of begin the actual, or very beginning, sort of joy of doing C#. Okay, so the first thing we're going to do is we're going to open up Visual Studio. So I have Visual Studio Community version installed that is free to use. This is actually version 2019. I believe 2017, I'm not sure what the exact new one is, but any of the Visual Studios would work. I'd recommend 2019 is sort of a good enough sort of year for this IDE. And then the community version is free to install, so let's say you can't beat that price. So what we're going to do right now is, at the very top you would search for language, you would just search for C#. So I'm just going to get rid of this, but you would just type in C# for the language you want to choose. And you want to go and find, if I can scroll down here, you want to find console app. So this is going to just allow us to create a regular terminal-based program, the same type as you've done in 135 and 202. So it's rather boring to do terminal-based programming, but you want to just get the idea of C# down before we really start getting into any more fun stuff later in the semester. So I'm going to go ahead and click on next. I'm going to click this and click next. And now I already kind of began this, but of course it would give you it would just say something like project 1. It would call very generic name it would give you. So of course you want to give it a proper name. So for this one, I'm going to just use first project as the project name, and the location. This is very important to know exactly where you want to save this file. So if you're using any of the OIT run labs, where very likely our EGG202 labs will be in, you want to choose your network drive. So myself or the grader will sort of, before lab, for your first actual lab, we will sort of tell you where you want to save your file, just to make sure that you don't accidentally save it in some downloads folder, some folder where what will happen is if you save it in non-network drive, after you restart the machine, your project files will be destroyed. So you want to make sure you save it in network drive where it will be saved. So if you do, if you want to just maintain your files, your project files, it will be maintained after you restart your computer. And in fact, for OIT run labs, if you want to work on your project, maybe I think in the TBE sort of A311 lab, that one has Visual Studio installed, and that sort of drive, the network drive in that lab will be the same as in any OIT run lab. Now, if you have your lab in some non-OIT based lab, there's also a specific folder you want to save your files into to make sure that your files will be preserved after you do restart your machine. And now, of course, we will go over that with the grader and myself. And then, of course, for .NET Framework, I would just say always pick the newest one is always the best one. So let's go with that one. Let's go ahead. I'm going to pick my folder actually. So I'm going to go to Browse. And I'm going to, I guess for right now, just to make things rather simple, I'm going to go to my downloads, or sorry, not download, desktop folder. So on my OneDrive, I'm going to click on Desktop. And I'm going to go ahead and just create a folder right here. So I'm just going to right click and just say folder, maybe just say EGG202 video projects, I'll call it. I'm going to select this folder, and it will save this current project, first project, into this folder. Let's go ahead and hit create. So once the project is built, so what happens is if you're using an older version of Visual Studio, at the very top, it might give you this message saying that please update to the newest version of Visual Studio. This version is not supported anymore. You can do that. So you can either use 2022 or you can use 2019. Either one will be just fine for this class. But anyway, this is going to be our sort of our editor, our ID after we sort of create the project. Let's go ahead and just sort of show how this looks like in our folder. So I have this folder I created earlier right here, EGG202 vids. If I click on this, there's my first project folder. And here's all of our stuff. But for right now, the important thing to consider is going to be this file right here. So first project.sln. If you do want to reopen up, let's say you worked on your program for a bit, you saved it, and you closed it, you want to open up this file, and it's going to just sort of open up Visual Studio. So let me go ahead and just sort of just take this and close it, and then just double click on this file right there, and it loads up Visual Studio right back to where we were. Just give it a second. And there we are. So that's how you can reopen up a project if you, let's say, you save it or you close your program. That's how you get back to where you were. Okay, so that's going to be just a very preliminary right there. Now let's go ahead and actually start writing some code in C# and just sort of try to compare and contrast this with C++. All right, so you may notice right here in this program, you see this static void main. That's going to be just the same like in CS135, that int main is going to be that starting function in C#. Then you might notice this class program wrapped around main. So if you've done C++ object-oriented C++, so CS202, then you are familiar with classes. So a class is just a custom data type, and just like in Java, C# everything has to be in a class in order for it to work. Then namespace first project, just a way to, I guess you can include multiple types you can add in here, and it will, if you have other sort of namespaces created with the same types, it will keep them separated. So namespace is a way of separating different classes from each other. So anyway, let's go ahead and just sort of get into how to write the code here. So what is a sort of a CS class without the classic hello world, right? So let's go ahead and write our hello world right here in main. So of course, as always, main is going to be a starting function. So I'm going to go ahead and say console dot write, and I'll print write line, and of course, hello world. So you can't really avoid that anymore. So we're going to have this hello world right there. So of course, at the very top, you can hit start, which is going to just run this program. Let's give it a second to compile. And right away, it closed. So if you hit start or F5, it's going to just right away run your program. So what happens here, the problem is that after it outputs hello world, it's not going to keep the terminal open. So if you want to be able to run this where it's going to keep a terminal open, you want to hit Control F5. So on my keyboard, I held down Control F5, and after it finished, it basically keeps this terminal open. So it's a way of going back and forth between debugging mode and regular mode. So we'll go over debugging mode and regular mode later on. So that way, a debugging mode means that you can have this Visual Studio IDE is a very nice and powerful debugger with it, which is a very nice debugger you can use to help sort of debug your program with any kind of problems. So for right now, we're going to basically just do Control F5. So it's going to have a terminal sort of display after it's done. But we can see here, it printed out hello world. So there we go. We first have our first program, and we have our infamous hello world right there. Now, of course, if I would just say just write, not write line, then it's not going to actually output a new line. So this is just very basic stuff right here. And you see it has hello world, and then right there side by side has this sort of prompt that tells you to press any key. And of course, like in CS135, you can put a /n. Just like in C++, it's going to sort of have the escape sequence. So we can see hello world was printed out, and then a new line. Now, you may wonder what's the difference of doing the following. So I'm not sure if write line is going to flush the entire output stream out, but that might be the case. So I guess write outputs out a line, but of course you can put a /n over there. Now, of course, whether the output stream will flush or not doesn't really matter for these simple programs, but very much like C++, you have end L and you have that /n, sort of the same idea over here. Okay, so now it's time to go past this infamous hello world in C#. So we're going to now go into just doing some basic input and output for right now. I might go into some looping structures in a later video, but if statements I'm not going to cover in these, and they're actually if statements in C# are identical to if statements in C++, so you will either you already have or you're going to get into your general decision structures later on in your 135 class. So it's the same idea in C#. So I might talk about that a little bit, or I might not. I'd rather just sort of go into really the differences between C# and C++. So anyway, of course, in order to do this, we're going to have to declare a few variables. So in this program, we're going to have to, so we're going to basically compute the volume and area of a cone. And we're going to want to read in the radius of the base of the cone and the height in order to compute these two values. So the first thing we'll do is we'll declare some variables. So I'm going to just remove all of this. I'm going to create a variable here for double radius and then double height. So far, very similar to CS135 or C++ programming. Now, the variables that you define here in main are going to be only in this main scope. If you want to have, how shall we say, global variables, you would define them above static void main. Now, right here in this area, this is not really considered global in a sense. They're really instance variables of the class, but if you haven't taken object-oriented C++ yet, then of course we're going to consider this as just global, I guess, for right now. Now, we're going to want to create some type of a global constant. So I'm going to have our constant for pi. So const double pi equals, I'm going to say 3.14 for right now. So we declare this constant up here globally. So now we have all of our variables defined. Let's go ahead and just simply do some basic input and be able to read from the user. So for reading input, it's not going to be as simple like it is in C++. It's very Java-like in terms of how it reads an input. So everything that's going to be read in from input in the C# is always read by string, and you have to convert the string into a double or into an int. Luckily, there are functions in C++ that will allow us to convert from one to the other. So the first thing I'm going to do is I'm going to prompt the user for input. So I'll do it sort of two ways. I'll do it in this video. Let's go ahead and just first have our input, or sorry, our prompt message. So console dot write, and I'll just say enter enter radius, like that, which will just prompt user for something. Then we'll have radius is set as console dot read line, and of course we have to convert this because right now console.readline is going to be a string type, and we can't store a string into a double. So there is a sort of a library or a function in C# to convert this. So I'm going to say double dot parse. So luckily this ID really does remember. I can't remember the actual function names, but anyway, this is going to take this console.readline. It reads in one line. We're going to pass this string into this function double.parse, which will return this in double form. Now, of course, if it's invalid input, you could use the if statement or use a try-catch type block to be able to verify if this is actually going to work. But we'll assume for now it's going to just work. We're going to pass a valid sort of type into this program. Then we'll have console.write, just write to the user, enter the height. Then I'm going to say height equals double dot parse. Then we'll say console dot read line, which reads an entire line as a string, just like that. So this is going to be the standard way. So I mean, there is some similarities here from C++. This is similar to saying cin radius. We're reading in this input, and we're going to store it into this radius variable, and same thing for the height variable, just like that. So now let's go ahead and run this, and let's run this actually in debugger mode, so we can see what the variables contain. So of course, the very, I don't want to say it, but the very noob way of being able to check to see what's in your variables is to simply cout from 135. Or if you've ever done programming, it's a very, I guess, poor man's version of a debugger. But we want to go ahead and be a little smarter. Let's use a debugger so we can see really what's inside the variables as we read through this. Let's go ahead and do this next. Okay, so to run a debugger on your program, the first thing you have to really do is create a breakpoint. A breakpoint is a spot in the program that's going to stop the program from running, and you'll be able to check and see what's going on. So typically, a debugger will help you see the flow of execution, so you know what line is sort of running and what order everything is running in. And of course, you can check variable contents as well as you debug. So the first thing we're going to do is we're going to just create a breakpoint in our program. So looking at the mouse over here, this gray area here will allow us to select a line to debug on. So I'm going to go ahead and just for now hit this line 22, click right there, which is going to just cause a breakpoint to happen. So the program will stop at this point. Now, in this example, the program stops on a read statement, which is sort of not the best example of debugging, but if we didn't have any read statements, if we had several statements in C# one by one would just sort of calculate and so forth, then a debugger is sort of going to stop on those lines. So we'll add this program some more later on, and we can kind of see what happens as we calculate stuff. But just first go over this very first simple example of debugging. So now we have to run our debugger in debug mode. So remember, F5 runs our program in debug mode, and Control F5 runs it in regular mode. So remember, regular mode means that the terminal is still going to display even after the program is done. Debug mode, the terminal automatically turns off. So since we are trying to debug right now, F5 we're going to use to debug our program. Let's hit F5 and see what happens. So I hit F5. Now our debugger stopped. It didn't really stop, but on this line 19, when a read happens, the program has to halt and wait for input from the user. So I'm going to type in for radius 3.5, hit enter. So now the program actually, sort of ran these lines and stopped right here. But notice the very bottom corner of your screen. Here we can see all of our variables in our program. So these are local variables. Obviously, we're locally inside of a domain. We see that, I guess, args, that's not really relevant, but we look at radius. It has the value 3.5 stored in there. So it looks like so far so good. The height has the value 0, and they're both doubles. So this gives us an idea of what's stored in our variables. Let's go ahead now and just sort of run this. I'm going to try to now hit a value for height. So I think I have to actually go back. I have to hit F10, which tells the debugger to run the next line of code. So F10, let's hit F10. And now it's going to pop up. So I already hit 5 earlier by accident. But anyway, I hit F10, which F10 is going to run your code line by line. So I'm going to type in at 5.3, hit enter. And our program is now done. But we can see here that this red means that something updated on that line. And our height is now 5.3. Radius 3.5. So using a debugger, we can see that, yep, looks like everything is read incorrectly. So definitely a nicer way than using a cout statement. Now, of course, the debugger in Visual Studio is can be a little annoying at times because you have to hit F10 sometimes in a line. So it's obviously a debugger will be more usable, not really for input statements per se. Mostly want to use the debugger for later on for other statements, like when we're doing if statements and calculations and so forth. Okay, so let's go ahead and now get back to our regular program. Go back to actually adding more to this. So I hit F5 afterwards once our program was finished to exit the debugger. Now, the thing about debuggers is things started popping up. So even my bottom taskbar sort of also was displayed. So I like to hide that typically whenever I make videos because I don't want people seeing that I'm up late night recording videos. It's not a very professorial thing to do, but I guess unfortunately, working at night is sort of preferred by me. I'm not sure about how you guys are, but that's kind of me, how I like to do stuff. So anyway, now let's go ahead and now get into actually writing some more code to compute other values. I'm going to get rid of this debugger statement here, and just now I'm going to create some more variables. So I'm going to have a variable for double area and double volume. Now, of course, just like in C++, I could have had this all in one. I could have said double radius, comma height, comma area, comma volume. That would have worked as well. But I did like this just because, but that way also would have worked. Okay, let's go ahead now and just write some code here to compute sort of these area and volume. So I'm going to go ahead and just have area equals, so it's going to be pi r squared times by height. So I'm going to have just pi multiplied by math dot pow. So just like in C++, so math is going to be a class, and we have a pow function inside of math. I'm going to put in radius over here, comma 2, multiply it by height, and it has divided by 3. Now I guess dividing by 3 is not a very good way to write code, but I guess for now just kind of bear with me. Using a constant, like using a value, this is not a very good idea. You always want to use constants over using a literal, but let's just sort of go with this for right now. That's going to be our area. Oh, sorry, it's going to be our volume. My mistake. It's going to be our volume. So I'm going to go ahead and rename this. So we're going to assign the volume with this value. And then we're going to go ahead and compute the area now. So area is going to be pi r squared. So pi times math dot pow radius squared, and then we're going to have plus pi, multiply it by the radius, multiply it by the height. So that's really it. So we have these two calculations right there. So now let's go ahead and let's try go ahead and test this out. So I'm going to go ahead and put a debug statement at the very end over here, and we'll go ahead and run this in debug mode again just to see if our area and volumes are coming out correct. And then we'll go ahead and go into outputting this, and that's going to sort of finish this first basic video with C#. All right, let's go ahead and run this in debug mode again, just to make sure everything is working fine. So I'm going to go ahead and put in the radius, maybe just 3.5. Then I'll enter, let's say, a next one. Our height will be, let's say, 7.2, like that. So we can see our program stopped on this line. So our height actually has a value of 7.2. Let's look at our, oh, whoops, oh no, sorry, volumes. Let's look at our volumes. Our volume has the following value right there. So I'm going to go ahead and just sort of assume that I did calculate everything correctly. Now our area is still a 0 because when a debug statement at line 27 is a breakpoint, it didn't really run line 27 just yet. So we're going to go ahead and hit F10. So F10 is a way for it to run the next line of your code. So I'm going to go ahead and hit F10 on my keyboard to go to the next line, so to run that line. Now let's go ahead and go back to back to a terminal, but let's go ahead and look at our debugger. So area now contains 117.593. I'm going to just assume that it does work. So okay, I guess looks like everything is working correctly. So let's go ahead now and just sort of end this. I'm going to go ahead and just hit F5, which will just stop everything from running. Okay, so that was just, now we have everything computed. Now let's go ahead and just finalize this code by putting some outputs over here. And then I'm going to go ahead and sort of cover a few other ways of sort of reading this one line of input from our standard input. All right, so now let's go ahead and sort of output everything to the screen. So I'll sort of show two ways of doing the output. One way that's a bit more preferred and one way that's not as preferred, but both ways will work. I'm not going to be too strict about it in the EGG202 class or our labs. So let's go ahead and output the volume and area to the screen. So again, I'm going to have console, I'm going to use right line. I'm going to say volume equals, and then plus volume dot to string like this. So this is going to do a string concatenation. So I guess in C#, everything is an object. Even a double is an object actually. So I don't think doubles are primitive types like in C++. So volume, we can call its toString function. So it's going to convert this volume as a double into a string. And this is right here, the word volume is a string. So we take this string volume and concatenate it with this variable that was a double into a string form, which will output volume equals and then the actual volume. That's one way of doing this. Let's go ahead now for the area. Do it, which I think the more proper way, at least the way I think looks better on the eyes at least. I'm going to say console dot right line. I'll say area. I'm going to go ahead and put in this variable like that, and then say area. This way is sort of similar to printf in C. What happens is we're outputting area, and we're going to output, I don't know what this terminology is, but I think this is similar to JavaScript, where it has like this, I guess somehow it's about a variable, I guess, I don't know. But what happens is it takes this bracket 0, so to replace it with this variable area gets replaced right in here. It's sort of, I guess, a more, I don't know, a more nicer way of doing this, I guess. And then one nice thing is you want to output multiple things at once. Let's say I want to output, let's do one more line right here just to kind of show you what I mean. If I say console dot right line, I'm going to say just area is 0 and volume is 1, then I could just go ahead and just say area, comma, volume, if I can spell volume. this way what will happen is, it does look nice. You don't have to concatenate. We say area is 0, which area is it, variable area gets written over here, and then volume is 1, so the next element in this list, so 0 is area, goes in there, volume 1 goes right over there. So just a way to be able to output multiple things like that in a very nice structured kind of manner. Let's go ahead now run this and see what we get. So I'm going to go ahead and just run this in regular mode, so Control F5 to run this in non-debugger mode. So radius, I'll just say maybe 3.5, height will be 7.2, and here we are. So we can see right there, it first outputs volume equals 92.316, area is this, then the next line right here, it outputs area is, which is 0, let's replaced by area, is area variable, and volume is, then bracket 1, replaced by volume like that. So this was just a very simple type of program we have. So for our first or earlier labs, we'll be just doing simple things just to kind of get us up to speed with C#, if in case you haven't coded in a while or you haven't done any programming before. This will be a nice simple way to get us started. So this is our first video in the series. So hopefully this did sort of at least give you an idea of C#, and of course this hopefully gives you an idea that C# is not that much different from C++. Of course it has more bells and whistles than C++, but overall this should be giving you a little bit of an idea and give you some type of a more comforting to see that C# is not so much different from C++. So that's the end of the first video, so take care you guys, and until next time.